Welcome, welcome. We're going to do 211 and 212. We're starting our next to last packet. Exciting. So our answer here is D and C. If you missed it, let's take some notes and figure these out. Now this is kind of a tricky question, although I love these because they have to do with probabilities. So a complex electronic device contains three components, component A, B, C, and D. So it kind of reminds me, I'm just going to use an example of a scissors. There's three pieces here. This could fail, this side of the blade here, this side of the blade, or this piece right here that's holding it together. And so notice if one of the blades goes dull and it doesn't work, then the scissor won't work. Or if the other side of the blade goes dull, the scissor won't work. Or if this thing falls apart, the scissor won't work. You can throw it away. So it makes sense that certain components that make up three components, the probability of failure for each component in any 1 year is these numbers. So what does this mean? This is the probability of A failing. So the probability of A failing is 0.01. And the probability of B failing is 0.03. And the probability of C failing is 0.04. And so hopefully that makes sense that it's a very low likelihood. I mean, I've probably had these scissors a few years now. It's very rare that maybe this piece goes bad or this piece goes bad or that piece goes bad. There's only three pieces to this scissors. But maybe one of these has a higher likelihood of going bad for whatever reason. Now, each of these are shaped slightly different. So maybe it was a little harder to sharpen this one because it was shaped a little different. This one's straight, so maybe that was easier to sharpen. And maybe this piece in the middle gets the most wear and tear, and so that maybe is why that piece has a higher likelihood of failing. However, if any piece fails, the device fails. So how do we calculate the probability of any of these failing? And that's when we get into our probability rules. So as long as each component is independent, we should be able to multiply their probabilities since they're independent. So let's go ahead and try that. The probability of A failing the probability of, what is the probability that the device will not fail? Oh, that's interesting. I have to calculate the probability that it won't fail. So this actually would be a difficult probabilities question to do because it's any combination of these. Any of the three mean this one could fail, but maybe only this one fails, but maybe only this one fails, or maybe these two fails. Lots of combos. Now, they've actually asked for an easier question. What's the probability that it will not fail? Well, that would be the probability that A doesn't fail. So the probability that A doesn't fail should just be the complement. 99% of the time A doesn't fail. And the probability of B doesn't fail would be 97% of the time. And the probability that C doesn't fail would be 96% of the time. So the probability that nothing fails at all would be these three events happening simultaneously. And once again, if they're independent, I can multiply them all together. So when I multiply these three probabilities together, this is the probability of no failures and I end up getting D. Now let's take a look at 212. A large sample that's 98% confidence interval for the proportion of the hotel reservation that canceled on an intended day is this. So if we do it in a calculator or we do it by hand, we should know what this means. So this would mean your actual parameter. So it looks like it's a proportion, a confidence interval for a proportion, and it looks like the number is somewhere between, this is almost 5% and that's 11%. So it's between 5% and 11%. So somewhere between this, we believe, is the true proportion of hotels that had to cancel. What is the point estimate for the proportion? Well, the point estimate would be somewhere exactly inside of there. That's not the true proportion, but it's at least the point estimate. So to do this, it's simple mathematics. I can subtract the 2. And I get 6%, so that makes sense. It ranges by 6%. And then I just have to cut that in half. So half of that is 0.34. So that is my margin of error. So my point statistic is some number directly between 5 and 11 plus or minus 0.034. So I merely add this to 5, or 4 more specifically 0.48, or subtract it from there, and I probably should do both to just double check my math. So if I add that, I get 0.08, and that is my answer. And again, notice the only one that made sense halfway between 5% and 11% was this one to begin with. The other ones don't make sense. And that's what a point statistic is. It's actually this number right here. And this is the margin of error, and this is called my point statistic, or my point estimate. Thanks for joining us.